Let us study force acting on a current carrying conductor in a magnetic field. So for that we need one horseshoe magnet and one current carrying conductor. Either a copper wire or aluminium wire we can see. Then through that we have to flow the current. So that particular time on that conductor how the force is acting, that we have to study. So first with the help of a diagram we will study how force is acting on a conductor. For that I am using one horseshoe magnet. This is its north pole, this is its south pole. We can say that we are keeping in such a condition. Then we are passing the conductor in such a condition. Now I am drawing the diagram. Here I am keeping one conductor . This is the south pole, this is the north pole. Now here I am connecting with the help of a wire. Such a way we have to connect to the conductor. Conductor means a wire. Now little enlarged condition I am showing you here. Then this is I am connecting with the wire. That means the same wire only. That way you can think this is little enlarged condition shown. Now we are connecting it on a stand. Here also I am keeping a stand for holding the conductor. Conductor means a wire. Now here I am making the stand. Stand here. Now through this wire we are passing the electric current. I am passing the current through here. Here means we can hold the magnet again on a stand. We can fix it and keep. Now, so what I am doing here, stand I am making here. For this magnet. Then the wire I am passing through here. Such a connection is there. Now you can see that here one stand is there for holding this wire as well as this conductor, and here one stand is there that is for holding the magnet in such a position. Through that we are passing the conductor. Now here a cell connection I am doing. here positive terminal, here negative terminal. Then here I am making the key, that means a switch connection. Now as and when switch is in on condition or key is closed, you can find that current flow is taking place from positive terminal to the negative terminal. As a result of it, you can find that current flow is taking place from upside or top to bottom. From upside to downward direction, current flow is taking place. Now, as and when current flow is taking place, you can find that on this conductor, conductor means this wire, around this conductor, a magnetic field formation is taking place. You people already studied the same in right hand rule. Current flow is taking place from either up to down or from down to upward direction. That particular time you can see that magnetic field formation is taking place around the conductor. So this thing again we can connect with the cell as well as key. So you can find that through this conductor current flow will take place. So we can say that we people already studied that. Imagine that you are holding a current carrying conductor in your right hand. So you can see that the flow of current that is showing by the thumb, at the same time the flow of or movement of or magnetic field showing by the curled fingers, that already you people studied. So here the same thing is happening. Now current flow is taking place from up to down or from down to upward direction also, if you are changing the terminal of the battery. So either from up to down or from down to upward direction current flow can take place. As and when current flow takes place, we can say that around the conductor there will be the formation of magnetic field. Now the magnetic field, how it is taking place? In the right hand rule that I had already shown you here. Such a way, if you are holding the conductor in your right hand, we can say that the thumb shows the direction of the current, curled fingers shows the direction of the magnetic field. That is only shown in this figure. So here we can see that same way magnetic field formation is taking place around this conductor. At the same time, when we are keeping the horseshoe magnet in such a way, we can say that here one place north pole, other place south pole will be there. From north pole to the south pole there will be the magnetic field formation. So here we can see the north pole as well as south pole of the magnet. From north to south pole there will be the magnetic field formation. So here from north to south magnetic field formation will be there. Around this conductor again there will be the magnetic field formation. Here around the conductor, as and when current flow will be there, that particular time magnetic field formation will be there. In case of magnet, north to south pole magnetic field formation is taking place. There means electricity is not required. Now here, as and when we kept such a conductor inside the magnetic field or inside the magnet, as I told you, such a way if you are keeping, you can see that here in between these two poles there may a magnetic field formation is taking place. As I showed you, such a way magnetic field formation taking place. At the same time around this also magnetic field formation taking place. Then once here magnetic field formation will take place, it tries to push inward. At the same time here in between the poles of the magnet, there also magnetic field formation is there. That magnetic field pushes the conductor outward direction. So this thing we are going to study through other rule, that is known as Fleming's left hand rule. Fleming's left hand rule. Now, in Fleming's left hand rule, you have to use the left hand. Then you have to fold these two fingers. Then other fingers, that is, this is thumb, this is the index finger, this is the middle finger. This is the thumb, this is the index finger, and this is the middle finger. You have to hold them in such a way. That means this index finger shows the direction of the magnetic field, thumb shows the direction of the force on the conductor, and middle finger shows the direction of the current. Now we will hold it in such a condition. Here you are seeing the direction of the current. So I am keeping this middle finger. Middle finger shows the direction of the current. Thumb shows the direction of force on conductor. And index finger shows the direction of magnetic field. Now we have to keep our left hand, these three fingers, thumb, index finger and middle finger, in such a way that they each of them perpendicular to each other. That means this and this should be perpendicular, 90-degree angle, such a condition, and this should be 90-degree angle, and again this and this, they also should be in 90-degree angle. So we can say that we have to hold each and every fingers, these three fingers, we have to keep it in perpendicular direction. That means mutually perpendicular to each other. Such a condition we have to keep. This and this perpendicular, that means 90-degree, this and this 90-degree, this and this 90-degree angle, such a condition. Now this thing we will relate with the force acting on the current carrying conductor in a magnetic field. How we will be connecting or how we will be keeping it. So this is the current carrying conductor, or we can say this is the this middle finger shows the direction of the current. So this one here, now you see from up to downward direction current flow is there. So I am keeping it in such a condition. Afterwards this index finger I am keeping towards this direction, magnetic field is showing. Then this thing, if we are keeping current, or we can say middle finger in the direction of the current, then the index finger towards the magnetic field, then we can say that this thumb shows the direction of the force acting on it. So according to this rule, we can say that here, if the current is flowing downward direction, the force acting will be towards outward direction. This is outward direction. So we can say that this thing will move towards outward direction. So we can say that the force acting on this conductor will be towards outward direction if we are flowing the current from up to or top to bottom. So we can mark this thing as C. Now if we are changing the direction, here now positive terminal to negative terminal, such a way current flow is taking place. Now suppose if we are changing the terminal, that means here now negative terminal, then here positive terminal will be there. We can say that the current flow will be reverse. So we can say that such a way flow will be there. from down to upward direction flow will be there. Such a way current flow will be there. So in such a case, what will happen? Now we can say that if the current is flowing from up to down to upward direction, that particular time, first how we kept it, current flow downward direction, magnetic field in such a condition, then we can say that the force acting on the conductor towards the outward direction. Now what I am doing, you see. Now the current flow is towards the upward direction. So same situation we have to make the arrangement same to same. So you can see that current flow towards now upward direction, magnetic field in the same direction. Then we can see that the force acting on this conductor towards inward direction. This sign keeping like this and this sign keeping like this. Then you can see that the thumb is directing opposite direction. We can say that other direction, inward direction we can say. So we can say that the conductor pushes inward if we are keeping or if we are sending the current from bottom to top. So we can see that here the conductor pushes inward. Here conductor pushes, if the current is flowing from up to down, the conductor pushes, it pushes outward direction. At the same time, if we flow the current from bottom to top, you can find that this conductor pushes inward direction. Now here, this conductor pushes outward means this way its movement will be inward direction, means this conductor will push inward direction. So same thing here, this is the conductor. Depending upon the flow of current, we can say the movement or the force acting on this conductor either towards outward direction or towards inward direction will be there. So this is happening because of the magnetic field forming by current carrying conductor as well as the magnet which is kept, or the conductor which is kept inside the magnet. So we can say that such a way force acting on this conductor is happening because of the current carrying conductor, one thing. Second thing, magnetic field formation. One thing, magnetic field formation is there. That magnetic field is forming by two things. One is current carrying conductor forming magnetic field, as well as this horseshoe magnet is forming magnetic field. Both the side equal force is occurring. Magnet is acting force, at the same time this conductor also acting force. With the help of both the force, their movement is happening to the conductor. So you people already studied Newton's third law of motion. For every action there will be equal and opposite reaction. Now we will study what is electric motor. Electric motor means what? It is a device which can convert electrical energy to mechanical energy. Now we will study with the help of a diagram what is electric motor. This is the figure of electric motor. Electric motor means what? Here one rectangular loop, is kept in between strong magnetic poles. Here now this is the rectangular loop that is kept in between two poles of the magnet. This is the north pole, this is the south pole. Then here we can say that magnetic field formation will be from north pole to south pole. Here we can say that magnetic field formation will be there. Magnetic field formation means the force is exerting by the magnet from north pole to south pole. At the same time, we can say that around this, here from this end, I am writing here A to B, then C as well as D. So we can say that 4 sides I made now, 4 sides are there here. AB side, BC side, CD side as well as AD side. Now here from A to B current flow will be there, then B to C current flow, C to D current flow, again from D to this way direction till here. So we can say that current flow from here it begins. This is the positive terminal of the battery. From here current flow starts, then it passes like this. Again current flow taking place from A to B, then from B to C, again from C to D, then from D to this direction, and at last it will reach to the negative terminal of the battery. Now once here, as and when force exerting by north pole to south pole, or we can say magnetic field formation is from north pole to south pole. At the same time, as and when current flow from this terminal to this terminal. Meanwhile, here we can say that a force is exerting on this side. That means this side as well as this side. This side as well as this side, no force is acting. Why here no force is acting and here no force is acting? Because direction of the current as well as magnetic field parallel to each other. Here we can say that this is magnetic field formation, here the current flow, both of them are parallel. So we can say that magnetic field as well as current from B to C parallel or parallel to each other. As a result of it, no force is acting here. There will be, because of that, there will be no force on this side. That means from B to C. Similarly, if we are seeing from D to A or from A to D, again we can say that no, from north pole to south pole, again magnetic field formation will be there, as well as the current flow, that also will be parallel. This as well as flow of the current, both will be parallel to each other. As a result of it, even A to D or D to A, there will be no force. Then here force will be from A to B as well as C to D. For studying that, we have to study Fleming's left hand rule. We had already studied about it. Now how it will work, we'll see. Now in this case, north pole to the south pole magnetic field formation will be there. Here magnetic field formation north to south, current flow from down to upside. Then we have to hold it in such a way. First magnetic field we will show. We had already studied. This is the index finger, this is the thumb as well as this is the middle finger. Index finger shows the direction of the magnetic field, then middle finger shows the direction of the current, and the thumb shows the direction of the force. Then here now the direction of the current towards the upward direction, this way. That means now current is towards the upward direction, then magnetic field towards this direction from north pole to south pole, and the force towards the downward direction. Here we can say that current flow from bottom to top, current flow, that is shown here. Magnetic field this way is shown. Why? Because north pole to south pole, and the motion force that is towards a downward direction. So we can say that in this case current, in this case current upward direction, and force downward direction. Current upward direction, force downward direction on this arm or at this side. Now here on this arm what is happening, we'll see. Direction of the current is shown, that is current downward direction. Now towards where force will be, let us see. Now magnetic field from north pole to south pole. So magnetic field I made it north pole to south pole. At the same time current flow downward direction. Then we can say that here this is the force will be exerting towards upward direction. So we can say that on this arm, here I can say, on this arm or side, we can say side CD, current will be flowing downward, force will be acting towards upward direction. Then magnetic field will be towards north to south, same direction will be there, same way. Here also north to south magnetic field, then magnetic field formation towards same direction will be there. Now this thing, just I am showing you. This is now copper wire is there, but with the help of iron wire I made such a arrangement. After that, one split ring they used here. Split ring means such a way one ring is there, such a way one ring. Then its central part has cut. But this is a ring, it is full ring only, just a model like I shown here to you, I am showing you. So such a ring, central region a cut is there. Then these all things won't be there. Such a way one ring taken, afterwards the central part has a cut, a slit is there. Or we can say this is known as split ring. As there is one slit, a cut is there. Because of that, it is known as a split ring is there. Now that thing only connected here. Here one round shaped container is there. We can say that such a container, its a top part as well as upper part is open. This side also open, this side also open. So this is known as a axle. On that only they attached such a split ring. Now on this split ring, this rectangular shaped loop has connection, attached and kept. Then after that, here one carbon brush, here again one carbon brush is there. Now as and when force is exerting on this arm will go downward as this. Now here I kept here, as and when force exerting, because here from north to south, at the same time on this also, on this arm as well as on this arm, force is exerting. As a result of it, this arm move leftward like this. As a result of it, this arm will reach to here. So we can say that half rotation over. Again it turns here. Then we can say full rotation over. Now again I am turning like this. So half rotation, again it is moving, full rotation, again coming half rotation. But as and when this loop moves, along with that, this split ring also will rotate. Even we can say that this split ring is attached on this axle. So this axle also will rotate. This thing also will rotate. Even this split ring also will rotate. Along with that, we can say that this attached ring also will, or this loop also will rotate. Like that. Now, how it is rotating? For this rotation, here the current flow as well as here the magnetic poles are there. With the help of that, here this rotation is taking place. Like that. So at first, when A to B this direction is there. This arm is at this side. So we can say that the force acting on this arm will be towards a downward direction. Now when this is coming towards here, like that is there, once it's a half rotation will over, this CD will come here. Once CD will come this side. So again what we can say, as and when CD is here, the flow of current will be from here till here. So that particular time its force is towards a upward direction. But once this is coming towards here, current flow will be from here to there. At the same time, its force will be towards a downward direction. That means which arm is coming and lie here, either AB arm or CD arm. So we can say that direction of the force will be towards downward direction. It may be AB arm, or when it comes here after half rotation, that particular time here it will be CD arm. So that particular time its force will be towards the force exerting on this arm always will be towards a downward direction. But which arm is coming, that may be AB arm or maybe CD arm, like this. Now we can say this is a AB arm, so force is directing towards a downward direction. Now I am rotating half, like that. So as a result of it, this arm came here. Now we can say that CD arm. On CD arm again force is acting downward direction. Again I am turning once again. So we can say that now AB came, before it was lying here, this AB arm. Now AB arm came towards again here after one rotation. So we can say that again force is acting on this arm towards a downward direction. Now this process keep on occurring in anti-clockwise direction. Anti-clockwise direction. This process keep on occurring, non-stop condition we can say. So we can say that that is in anti-clockwise direction. This process is happening inside the electric motor. So electric motor is used in electric fans, mixer, then grinder, even we can say that refrigerator, washing machine, etc. What is meant by electromagnetic induction? This electromagnetic induction means because of the help of a magnet, electricity producing on the conductor. Conductor means a wire through which electricity can flow. So here now electromagnetic induction is explained at first by a scientist. His name is Michael Faraday. Michael Faraday. Now, here two types of experiment shown here. The first experiment, here one bar magnet kept, a magnet it is. So magnet is having the capacity to produce magnetic field. Now because of that, here one wire is kept, one copper wire is kept. This copper wire keep on moving either this way or this way. So here the movement is shown as from A to B, B to A, like that way movement is shown just above the magnet. As a result of it, electricity started to produce in this wire. Now electricity produced or not, for seeing that or for detecting that, here one galvano meter connected and kept. That galvano meter is looking like this. Such a figure is there. Now galvano meter, its central region has one needle. Now if electricity is flowing either towards this direction, then needle will move towards, needle will deflect towards this direction. If current is flowing through this side, then towards here magnetic needle will, or galvanometer's needle will deflect towards here. So this is the galvanometer. Galvanometer is used to detect the flow of current, whether it is flowing through this conductor or not. For that we are using Galvano meter. Now here means only the symbol I shown, here it's a diagram I shown. Now this is only using for finding whether current is flowing or not. Current is flowing or not, for detecting that. That means its needle will deflect either towards rightward or towards leftward. That means if the current flow is taking place from here till here, then it will be showing deflection towards here. If the current flow is taking place from here till here, then deflection will be showing towards leftward direction. So here current is producing. Induction means producing or production. That is happening just because of the movement of wire or the conductor just above the bar magnet. Now this is another experiment. This is again showing that whether electricity is producing or not. For that, here means one coil of wire kept. Now this is a galvano meter connected here. This is just a coil of a loop of wire, we can say, or coil of wire. Now this is the solenoid. It is a solenoid. Here now we are flowing or passing current through this solenoid. Now switch is in on condition, current is flowing through it. Then this solenoid will act like a magnet. As a result of it, you can find that here the movement, or we can say electric current production, will take place. Here just we are passing the current through it. That particular time we can find that here again current flow will take place. On its own current flow is taking place, or we can say current production is taking place. As a result of it, galvano meter shows deflection. So here current is flowing from positive terminal to the negative terminal in the solenoid. As a result of it, you can find that this solenoid is acting like a magnet as and when we pass current through it. So then, as a result of it, if we are keeping this coil near it, then also slight production of electricity will be there. If we will move this, we can find that more production of current will take place. Or we can say that if we are moving this solenoid towards it, either this thing we are moving towards it or this thing moving towards it, then also you can find that there will be the production of electric current in this coil. Either we can move this solenoid or we can move this coil. Here, before I told you, we can move the coil up and down. Similarly, now if you are keeping this coil in the stationary condition and bar magnet if you are moving, then also we will get the production of, or we can see the production of electric current in this coil. Here means we didn't keep any cell connection, only one bar magnet is there. You can find that either you move bar magnet or you move the wire, you can find that production of or generation of current in this wire. Now here, this means as and when we flow the current through this solenoid, then only it can be act like a magnet. Once it will become or act like a magnet, either this thing you can move towards this coil or you can move this coil towards here. You can find that there will be the production of electricity in this coil. Or if you are keeping this solenoid by passing current near to this coil, then also you can find that there will be the production of electric current in that coil. Now, more production of current needed, then we have to displace them. We have to move the solenoid or we have to move the coil near to each other. Then we will feel that means if we are displacing, if we are moving this coil more and more forcible manner, or if you are moving this solenoid in a more and more forcible manner, you can find that more production of electricity will take place. What is Fleming's right hand rule. Right hand rule as well as Fleming's left hand rule, more or less same. But for left hand rule, we have to use the left hand. Now right hand rule, we have to use the right hand. Now in the left hand rule, thumb points to the direction of the force. Here now thumb points to the direction of the motion of the conductor. Let us see now. Fleming's right hand rule. Here we are using 3 fingers, thumb, index finger, then middle finger. Here thumb shows the direction of motion of the conductor. Then index finger shows the direction of the magnetic field, and middle finger shows the direction of the current. Now how to hold that I'll show you. Here we have to hold these 2 fingers, just folding condition. Afterwards this should be in the perpendicular condition, this again should be perpendicular, this again perpendicular condition. So we can say that this thumb as well as index finger in between 90-degree angle should be, then again in between these 2 90-degree angle should be, again in between this finger as well as middle finger again 90-degree angle should be there. That means we have to hold the thumb, index finger and middle finger mutually perpendicular to each other. As a result of it, the thumb shows the direction of motion of the conductor, index finger shows the magnetic field, middle finger shows the direction of the current. What is an electric generator? Electric generator is a device in which mechanical energy is used to rotate current carrying coil in a magnetic field to produce electric current. In the electric generator, a coil of the conductor is kept in the middle of the 2 poles of the magnet. Magnetic field is moving from north pole to the south pole. Now here current flow will be taking place from A to B, then B to C, C to D, again this direction and through this and this way, again it is coming to here. Like that way flow of current is there. Now for the flow of current as well as for the production of the current, here the movement, the induced current towards which direction will be there, motion of the current or motion of the conductor towards which direction, then magnetic field towards which direction. For seeing that, we have to study Fleming's right hand rule. Now here the flow of current is taking place from A to B. Now at this point induced this magnetic field will be towards this direction, such a way. That means we have to keep the index finger towards the magnetic field formation towards where, that means the north to south, same direction we have to keep. Then motion of the conductor towards this direction. At the same time, induced current towards inward direction. This way it will be there, towards inward direction. Now, at this side, current flow from C to D. In that condition, again, magnetic field formation towards this direction, such a way, and the motion of the conductor towards such a condition will be there. We have to hold it in such a condition. Then magnetic needle, magnetic field formation towards this direction and motion of the conductor downward direction, then induced current towards outward direction. Induced current towards outward direction. Now, here as and when current flow, suppose current is flowing from here towards here and through here, like that way motion will means current flow is taking place. That particular time this coil will have a clockwise movement. So for showing that clockwise movement, I'll show you such a coil I taken. Afterwards a clockwise movement means a this way movement. After that it will move this way. Again clockwise movement, such a way, then it will go towards here. Again such a way. So this is clockwise movement. Now here as and when it gets a force, it will move towards clockwise direction. So this side of the coil will come to this side. As and when this AB side come to this side, direction of the induced current will be towards downward direction. At the same time this CD side will go to this side, then flow of current will be from here to there it will be. Now once the movement or the current flow from here is taking place, so once it is moving or showing clockwise movement, so this side is coming towards here. As a result of it, while moving along with this coil, this ring as well as this axle, they together will move. As and when the whole thing will move, leaving brush B1 and brush B2, the remaining setup full will move. Once it is moving towards here, then this side here, once it is moving towards here, that means this AB side is going to come here. Once AB side is coming here, current flow will be from here till here. Then same way the movement will be reaching up to here. So this diagram once again I will draw and show you. Here the flow of current from brush B1 to such a way direction its movement, then it is coming towards here, again it is coming towards here, then it is coming again, it is rotating through here, then afterwards it is moving through here. This is happening first half. In the first half rotation, we can say first half rotation, flow of current is taking place from here towards here. From here its movement is taking place. At the same time from here movement is taking place downward. Then we can say that flow of current from here, then it is moving like that. Then here this brush is having only connection with this slip ring. It can slip. Why? Because this brush will remain in the stable condition, but this ring can be able to rotate. So this ring is known as slip ring. Similarly, this ring also known as slip ring. In the first rotation, we can say that this AB side, in the first half rotation, AB side is coming towards here. That particular time, AB side will get then direction from, we can say that instead of CD, once AB side will come here, CD side will go here. That diagram I will draw, then afterwards will explain. This is the coil, again here the axle connected and kept. Now here two slip rings connected. Now in this case, here now this is going to connect with this. Now here there will be the brush, and this side will be in connection here. In this case, this side upper part you can see. So B1 I am writing this side. Now here downside part, here its a connection will be there to the wire. This is the axle. Then afterwards here the brush connection will be there. Then we have to connect it with the external circuit, that is here only the Galvano meter connection. Now here two poles of the magnet will be there. Here in the first case, current flow from A to B. Once it shows half rotation, that means that this will go towards here in a clockwise direction. So that particular time, this side, that is CD, will go to opposite side. So I am writing now here, this is C, this is D, then this is A, and this is here now this is A, and this is B. Now once this side CD comes, then direction of the current will be from this side. Once BA comes this side, then current flow will be from B to A. Now first we will study this clearly, then we will go to that side. Current flow from A to B, and from B to C, then C to D, further it is passing through here, and it is coming and touching here. That means B2 as well as this slip ring, it is touching. Again current is passing through here, and through its behind it is passing, and it is passing through the brush, and it is passing like that, and it is passing, and it is reaching to here. Now once its clockwise rotation will take place, that particular time AB side will go to this side, CD side comes to this side. Again here the current flow will be taking place from here to D to C, C to B, B to A, again from A to this direction. Now B1, that means that the whole setup is rotating. So as a result of it, this B1 side came to this side. Now as a result of it, the current which is passing through here, that is passing through here. After that it is rotating. Once the current is coming here, passing through this slip ring, then through its backside it is moving, then passing through the brush, and through B1, then through this wire it is coming, and it is coming and completing its circuit. So here at first started from here, this side, next time from the reverse direction. That means first from this side current flow taken place, then its rotation took place, its clockwise rotation took place. As a result of it, the direction changed. The position of AB this side is becoming. Position of CD is becoming this side. Then current flow from this side taking place in the first case. In the second case, current flow from DC to BA, then passing through this side, and it is passing and it is reaching here. So we can say that every half of rotation, the direction of the flow of current is changing in the AC generator. Because of that, it is known as AC current producing generator. AC means alternate current producing generator. In the alternate current producing generator, every half rotation, the flow of current or the direction of the current reverses. Thank you.